Hello, I'm Sophie from the National Space Academy, and today I'm going to talk to you about what this had to do with protecting the Space Shuttle on Reentry. NASA's Space Shuttle was effectively a reusable space plane, and when it was up in space in orbit, for example if it had docked with the International Space Station, then it was travelling at a phenomenal speed of over 17,000 miles per hour. And to get back down to Earth and come through the atmosphere, it had to lose that speed and convert energy from one form to another. So that space shuttle, travelling at tens of thousands of miles an hour, slamming into the top of the Earth's atmosphere, causes the gas to get squashed. And as it gets squashed, it gets heated up to temperatures much higher than my blowtorch here. But this does mean that we can use this blowtorch as a good way of simulating re-entry. Now, if you saw my video a few weeks ago about simulating re-entry with a gas cooker and a marshmallow, it's a similar process. So what we're going to do is have a look at how good an insulator this tile is. So I want you to imagine our space shuttle has been orbiting the Earth high above the Earth's atmosphere, and it's going to come down at very high speed into the atmosphere. Now, as that happens, as it slams into the gases of the Earth's atmosphere, it is going to push them together, squash them together, and they're going to heat up just like our blowtorch here. The outside of our space shuttle, this thermal protection, is going to get incredibly hot. So hot, in fact, if I pull this away, you can see it's glowing orange. And yet, my fingers are feeling absolutely fine. So you can clearly see there that my fingers were perfectly safe from the extremely high heat at the blowtorch end of the thermal protection tile, because it was such a good insulator. But I want to show you a more dramatic way of seeing just how good a job this does at keeping the heat to that corner and stopping it from transmitting along the insulation, and in the case of the space shuttle, down to the shuttle itself. And I'm going to use my trusty infrared camera for that. This camera is going to allow me to see heat. What it does is it picks up the heat from here, and it turns that heat, which is in itself a type of light, turns that into a visual image that I can see. The brighter the colour on this image, the hotter the temperature of that spot is. So let's see just how good a job our tile does of keeping the heat in one corner. So here you can see I've got my camera fixed on my infrared or heat camera, and you can see that as soon as I turn the blowtorch on, it dominates the rest of the screen. The screen self-calibrates, so it will turn slightly darker overall to compensate for the ridiculous heat of the blowtorch. As I bring it into one corner of the tile, you can see that where the blowtorch hits is getting very hot. But that heat is staying very much to that one corner. Now, don't be fooled by the temperature measurement on there. The point where the blowtorch is touching is well above 130 degrees C. So throughout this video, I've been referring to this as a space shuttle insulation tile, but actually that's not quite true. This came not from the space shuttle, but from the Soviet and Russian equivalent of the space shuttle, the Buran. The Soviet space shuttle Buran, meaning snowstorm or blizzard, was remarkably similar to NASA's space shuttle. From the outside and from a distance, it was almost impossible to tell the difference. Construction began on the Buran in 1980, and in 1988 it conducted its only uncrewed, remote-controlled test flight. Unfortunately, the program was cancelled shortly thereafter, and the test flight model was destroyed in 2002 when the hangar it was stored in collapsed. So there you have it. When the space shuttle used to fly, it had to be protected from heat from re-entry, and some pretty nifty material engineering allowed us to make this very lightweight material that kept our astronauts safe. Maybe again in the future we'll get to see spacecraft like the Space Shuttle flying again. And if they do, and they want to be reusable, they are going to need a type of protection like this.